Hello, and in this video we're going to talk about the definition of a probability and also give a couple properties that are associated with it. So we're going to take one of the basic definitions of what a probability measure is, and it's the description of the likelihood of an event occurring with respect to its sample space. And usually people will calculate the probability in the traditional sense, namely the probability P of an event E is equal to the size of its event space divided by the size of its sample space. So let us just describe a couple properties of this probability measure. The first property is that all probabilities are always between 0 and 1. And the proof of this is very straightforward if you're interested. But what this pretty much says is if you calculate the probability of an event and you do it correctly, then you'll never get a number bigger than 1, and you're never going to get a negative number either. The second property says this, that the sum of all of the probabilities is equal to 1 as well. So if you have, say, 5 possible events, then the sum of all those events is going to come out to 1. And also, since an event and its complement is equal to its sample space, and E and E complement are mutually exclusive, then we can find that the probability of E plus the probability of E not happening must come out to 1. So this is then going to give us two properties. The first one says that the probability of E complement, or the probability of something not happening, is 1 minus the probability of an event actually happening, or the probability of an event happening is equal to 1 minus the probability of it not happening. And that's the third common property. So let us demonstrate these with a couple examples. So let's assume the first. Suppose that you flip 5 coins. Of course, heads or tails. So if I give you an experiment, then you should be able to find the sample space for that. So the sample space for this experiment is going to be the set of all 5 tuples, such as H, 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 H is one event, H, 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 T is going to be another event, all the way down to T, 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 T. So how many events are there? Well, by the fundamental counting principle, the size of S is going to be equal to 2 to the 5th, or 32. Now let us describe a particular event that we're interested in. So let E be the event such that you get at most 2 heads. So at most 2 heads is the set containing 0 heads, 1 heads, or 2 heads. This is what that description actually means. So 0 heads is going to be all tails, so T, 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 T. 1 heads is going to be the set H, T, 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 H, T, 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 H, T, 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 H, T, or T, 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 H. And then 2 heads is a little bit more complex, right? H, H, T, T, T. You can have H, T, H, T, T. And there's going to be a lot more here, but I'm not going to list them all. So how can we easily count the size of this event space? So notice here that that's just equal to 1. Also note here that's 1, 2, 3, 4, 5. But notice we can just count them because they're just combinations. Because notice the order of the H does not matter here. And also notice here the order does not matter. All of these are the same. So these are all combinations actually, namely 5 choose 2, 5 choose 1, and if we want to be more general, that's just 5 choose 0. So that means what? That means the size of our event space is going to be equal to the sum of the combinations 5 choose 0 plus 5 choose 1 plus 5 choose 2. So 5 choose 0 is always equal to 1. 5 choose 1 is always equal to 5. 5 choose 2, not sometimes always obvious, so we're going to just calculate that directly. So 5 factorial is going to be equal to 5 times 4 times 3 factorial, 2 times 1 times 3 factorial. 3's will cancel. 5 times 4 is 20, divided by 2 is going to be 10. So that's going to be 10. So that means the size of E is going to be equal to 1 plus 5 plus 10, which is going to be equal to 16. So let us recap what we have here. So since the size of E is equal to 16, the size of the sample space is equal to 32. Once we have these two things in our hand, we can calculate the probability. So the probability of E occurring is equal to 16 divided by 32, which is simplified to 1/2, or a 50% chance of occurring. So if you were to throw 5 coins 2 different times, then it's likely that one of those 2 tries you're going to have the scenario where you're going to have at most 2 heads. Let us do another example to summarize. So suppose you roll 3 6-sided dice. So what does the sample space look like? So S is going to contain 3 tuples, such like 1 1 1, 1 1 2, all the way down to say 1 1 6. You're going to have things such as 1 1 1, or 1 2 1, 1 6 1, all the way down to eventually 6 6 6. So it's like the 2-dimensional takes this up as 3 dimensions, since 3 things are changing. A little bit more complex to count by hand, but by the fundamental counting principle, this is going to be equal to 6 cubed. So 6 cubed is going to be 6 times 6 times 6, which is going to come out to 216. So that's the size of our sample space. So let us say that our event of interest is that the sum is, what kind of sum do we want? Say less than, say 17. So less than 17. So what's the smallest sum that you could have here? So the smallest sum is going to be 3. We can get a sum of 4, 5, 6, 7, all the way out to 16. So these are all the sums that we want. So we know 1 1 1 is the only possible way to get 3. Well, how are you going to get 4? Well, you can do 1 1 2, you can do 1 2 1. You could do 2 1 1, and we're going to go all the way out to 16. Well, that's a lot, right? So what if we look at its complement and see if that's easier? So what is its complement? Well, its complement is going to be the set such that the sum is greater than or equal to 17. So greater than or equal to 17 is going to start off at 17, and then it's going to go to 18. And remember, the highest number on a die is 6, so the highest value we can have is 6 plus 6 plus 6, which is 18. So these are the only possible outcomes that happen in the complement of E. So how can we get a sum of 18? Well, 666 is the only value that you could have. You could have 665 for 17, 656, or 566 in order to get a sum of 17. So there's only 4 possible events here. So the size of the complement of E is equal to 4. Alright, so let us go back here. What do we have? So we have 216 values. 216 values in our sample space. We have 4 values in our complement space. So that means the size of E must be equal to 216 minus 4, which is going to be 212. So that means the probability of our event, that is rolling a sum less than 17, is going to be equal to 212 divided by 216, which is approximately equal to 0.9815. So about 98.15% of the time, you're going to have this scenario happen. So let us summarize these properties that we've discussed here. So the first, the probability of an event is calculated by calculating the size of E over the size of S. Second, all probabilities are always between 0 and 1. The sum of all our probabilities is equal to 1. And the probability of the complement is equal to 1 minus the probability of E. Or the probability of E is equal to 1 minus the probability of E complement, which is pretty much what we discussed in this last example. And that's a general overview on 4 basic properties of probability. And in the upcoming videos, we'll talk about more advanced properties of them.